In 1980, 3 siblings were each given $1,000 as part of the inheritance from a deceased uncle. The siblings agreed to invest their money individually and come back years later to see who had amassed the most fortune. You guys don't have contests like that with your brothers and sisters, do you? Oh, your sisters don't have $1,000, but you do? Oh, okay. Okay, so here's the stories. The oldest brother, Alan, put $1,000 into the bank. Each month, he would add $62.50 of his own money to the account, or $750 a year. The sister, Bernice, invested her $1,000 in various money market accounts and earned 12% interest each year, compounded annually. Carl, the youngest, put his money into the technology stocks. Their value climbed according to a parabolic curve until it peaked at $20,600 in 1994. By 2008, the stocks had fallen back to the original value of $1,000. Poor Carl. Carl should have cashed in. Yeah, okay. So first of all, first thing we have to do today is determine which sibling's financial history matches the graph above. And then, how can you tell? So who goes with what? Okay, I'm hearing lots of things. Let's do one at a time. Who wants to go first? What you got? Alan? You think Alan is the line? Does anyone agree with him? Most of you? Okay, so somebody else besides Casey, tell me why you think Alan's the line. So he's adding a constant amount? Would that be kind of what you said? I mean, it's mostly what you said, except for one word, right? What one word did I change? Constant, right? You said adding the same amount. I just made it a little bit more mathy. Adding a constant amount. Okay? All right, who's next? We got to decide between Bernice and Carl. Okay, somebody else tell me why Carl's a parabola. So it goes up and peaks and comes back down. What's another way we could tell it's a parabola? Yeah, it says, look, parabolic curve. It says it's a parabola, okay? But it goes up, comes back down. Now that's not real mathy, but we got it, right? We understand it? All right. Which leaves Bernice being what? Whoops. Sorry, Bernice. That should be a C. Which one's Bernice? I know it's the only one that's left. Smarty pants. What is it called? It's not the line. It's not the parabola. It's this one. What's that called? Nope. It's the one we just finished doing. Right before that. We did logarithms and what together? Exponents. It's exponential. How do we know, besides that's only one left, how do we know that Bernice's is an exponential? Because there's interest, right? 12% interest. And it even says compounded annually, doesn't it? Right here. Compounded. We know that that's going to be the exponential. Okay, so we've matched each person with their shape, with their graph, right? Now we need to write their equations. Which one do you want to start with? Alan. That's what most people like to start with. Why? Easiest, right? It's the easiest. It's the line. So how do we write the equation of a line? Okay, I heard y equals mx plus b. That's the equation of a line, right? Does it have to be in that order in this problem? No. So do we know a slope or do we know an intercept? What do we know? So we know $62.50 a month or $750 a year. Which one of those are we going to use? $750, right? So what goes where? What do you want to put? 750x plus 1,000. We don't need to put equals y because it's already a of x equals that, right? It's already taken care of for us. What's next, Bernice or Carl? Bernice, if it's compounded annually, you remember we did y equals p 1 plus r raised to the x power, or t power, right? So in this case, that would be, what's the p? 1,000. 1 plus the rate. What's the rate? So 1.12 raised to the x power. Then we have Carl. We know his is a parabola. How do we write the equation of a parabola? Now we know that's the standard form, right? Or general form. Except that doesn't help us at all because we don't know A, B, or C. Well, we know C, don't we? We know C is 1,000, our starting point. You're going to have to remember all the way back to when we talked about parabolas. Where am I going to go? Lists and spreadsheets. I need some x values and I need some y values. How many points do I need to write the equation of a parabola? 3. Do I have 3 points in this paragraph right here? What are they? 0, 1,000. Whoa, whoa, whoa. I don't see 14 in that paragraph anywhere. Why did you say 14? Oh, because we're starting at 1980, and the next year that they tell us is 1994. Isn't that 14 years later? So does 14 make sense? Good. So if x is 14, what's the y value there? 20,600. And what's the last point? 28. 2008 is 28 years after 1980. 1,000. So what do we do with that information? I started a list and spreadsheet. So all my x's go in this column, all my y's go in this column. 0, 14, 28. You guys remember this now? 3 of you. Excellent. Okay. 1,000, 20,600, and 1,000. Now that I have this, what do I do with it? I need to add a page, so Control Doc to add a page. And I have to create a data and statistics page. I need to line up my x's, so I need to come down here and press and choose my x. I need to come over here and press and choose my y. Now it's starting to look like a parabola a bit, isn't it? Menu. What? Analyze? What? Which one do I choose? Regression. What type of regression am I trying to find? Quadratic. Boom. Get negative 100x squared plus 2800x plus 1000. Didn't we expect that 1000? Because we know C is our y-intercept, right? And when time was 0, he had $1,000, didn't he? Okay, so we have our three equations. Now, let's make sure they are correct. Let's go add a graph. Not that. Let's add a graph page. And let's put all three of these into our graph page. 750x plus 1000. 1000. Whoops. Tab. 1000. 1, 2 raised to the x power. Tab. Negative 100. Whoops. X squared. 2800x plus 1000. If I'm trying to match up my graph and this graph, it does not match. It does not look the same at all. What have I done wrong? Did I put anything in the calculator wrong? You saw me what I put in, right? Was any of it wrong? No? I got to change the window, right? Menu, window, window settings. What do I want my x values to be? Well, if I could either look here, I could look where it tells me I want my domain to be between 0 and 28. Okay? I want to be able to see that domain though. So do I want to put 0 and 28 if I want to see my domain? No. So let's go negative 1 and 30. How about that? Will that work? That's not what I wanted to do. Menu, window, settings. Will negative 1 and 30 work? Okay, I hope so. What about y values? What kind of y values do I have in this problem? I want to see my axis, so I'm going to put negative 1 to where? 21,000? Why in the world would I go to 21,000? Right, we know it peaks at 28,600 for the parabola. So hopefully, actually, let's go ahead and make this like 24,000, just for argument's sake. You'll see why in a minute. Okay? I know you can't see that red line very well on the screen. You can see it on my computer though, so if you're watching this video later, you'll be able to see that red line. Don't worry. You can kind of see a shadow of it if I tilt it like that. Okay? Now, do these look the same now? Much closer than before, right? Okay? Use the function to complete the table. Then tell which sibling had the most money at each given time. Who does this stand for? Alan. Who does this stand for? Bernice and Carl. Okay? So what should we do? Oh, so we can look at the table on the calculator? Okay, let's do that. Control T. The first one we have is at 750x, and we know that that's Alan's, right? So at 5 years, 4,750. At 10 years, 8,500. 15? Nope. 20. 16,000. And 25. 19,007. Whoa. 750. Is that what your table says? Yes? Alright, so what about Bernice? Where do I go for Bernice? Next equation over, right? Are you okay if I go backwards? So I'm already down at 25. Can I start at 25 for Bernice? 17,006 cents. Okay, look, so how did I know that was 6 cents? It doesn't say 6 cents, it says 10 cents. Look right here. This is a rounded number. The actual number will be down there on the bottom. Okay? So back up to 20. 96,046 and 29 cents. And then you need 10. Oops. 3,105 and 85 cents. And 5. 1762 and 34 cents. Are you with me so far? Are you getting the same numbers I am? Okay. So what about Carl? So I need to go over to the third equation I put in, right? What'd you get for 5 years on Carl? 12,500. Somebody else, what did you get for 10 years on Carl? 19,000. Okay, somebody else, 20? 17. Wait, less? Do we expect that? Okay, yes, all right. What about 25 years? Somebody else. 8,500. And we expected that too, didn't we? Okay. So after 5 years, who had the most? Carl. After 10 years, who had the most? Carl. After 20 years, who had the most? Carl. After 25 years, who had the most? Ooh, Alan. Okay, so far? It's given that Carl had $1,000 after 28 years. How much did the other siblings have at this point? How much did Alan have? And how do you know? How much? Oh, so you just used the table again? And just went down to 28 years? Good. How much did Alan have? 22,000 exactly? All right, good. What about Bernice? 23, 883,000 exactly? 87 cents? Yes? So if I go on my calculator down to 28, I can see that right here it says 23,883.9, but looking down here at the bottom, you see how it says 87? Well, we'd have to round it to 87, right? Any questions about that? All right, now let's use what we just found. We did a whole bunch of little calculations and stuff like that, which is all important to know how to do, right? But let's use it now, okay? After approximately how many years did Alan and Bernice have the same amount of money invested? Alan and Bernice. Which graph was Alan? The line. And which one was Bernice? Exponential. So I want to find this point of intersection right there, don't I? That's what I want to find. Can I do that on my calculator, or do I have to do it here somehow? If I hit Control T to get rid of my table, can I find that point of intersection right there? Yes. How? Wait, do I care about the parabola right now? Okay, it's distracting me. I'm going to go turn it off. I hit tab to make the parabola come up again. I'm going to go over here to this box and click the check. See how it's still there? It's just not graphing for me. Isn't that what I want? Okay. So now I want that point right there. Remember how to do that? Remind me. Menu. We always go menu first if we don't know what to do, right? Menu. Analyze. Intersection. It wants it on the left side. So I'm going to scoot it over there a little closer. There's the left side. There's the right side. What is my point of intersection? It says 27, 2.12E4. That's what it says. Now we need to decipher that. We need to translate it from numbers into what we actually need it to mean. Okay? Question is, after approximately how many years did Alan and Bernice have the same amount of money, and what was that amount? Approximately 27 years. Approximately how much money? What does that even mean? 2.12E4. 4 decimal places after the decimal. So that's where the decimal was. I need 1, 2, 3, 4 decimal places. How much was that? $21,200. Approximately, right? We know it rounded it for us, and we know that because if I go Control T real quick, and I go down to 27, just on Allen's, is that approximately 27 or 21,200? Yeah, it's 21,250. That's close, right? What about Bernice's? 21,324. Is that still approximately that? Yeah, that's why I put that little symbol in front. I didn't like hit a bump as I was writing my equal sign, did I? I used that approximately sign on purpose. Yes or no? Okay. So, what about number 6? After approximately how many years did Alan and Carl have the same amount of money? And then what was that amount? Which two do we care about this time? The parabola and the line. So I want to turn the parabola back on. So I hit tab and go to the parabola and turn it back on. And you don't have to do this. I'm just showing you that it can be done. I like to not be distracted by stuff that I'm not working with. That's the one I want to turn off this time, right? Because I don't care about Bernice right now. I'm sure she's a lovely person, but I don't care about her right now. So where do I care about now? What point am I caring about right now? Between the parabola and the line, so right there. So I can just do this exact same thing that I just did, can't I? What did I just do? Menu. Analyze. Intersection. Put it on the left-hand side of the intersection. Click. Put it on the right-hand side of the intersection. All right. I don't know about you, but that's getting pretty messy. I can't read that. Do you remember how to move it? I get the hand, so it's like this. I want to close the hand, so I do Control and then that middle click, and then I can move it around so I can get it to where I can see it. Remember that? So what it says is what? Approximately how many years? Here, this is what it says. 20.5, 1.64 E4. Is that what yours says? What does that mean? 20.5 years. How much money? What does this mean? 4 decimal places. 1, 2, 3, 4. How much money is that? Good. 16,400. Approximately, right? What about the last one? Bernice and Carl. After how many years did Bernice and Carl have the same amount of money? Which point of intersection am I looking for this time? Bernice is exponential, Carl is the parabola, so I'm looking for that one. So I need to turn this one back on. Which one am I turning off? The line. Okay. Menu. Analyze. Intersection. Left-hand side. Right-hand side. Oh. 22.7, 1.1, or sorry, 1.31 E4. What does it mean? What does it mean? $22.7. Whoa. I said 7 and wrote a 4. That was weird. Years? How much money? $13,100. Any questions? Of the problems above, one of the problems above can be solved algebraically without a calculator. Which one do you think it is? Look at the equations. Is it Alan and Bernice? Is it Bernice and Carl? Or is it Alan and Carl? Well, we just got finished doing exponents and logarithms, right? And if you had the choice, you wouldn't mess with those, would you? Okay, you did fairly well on your tests, right? But if you had the choice, you would do the linear and the quadratic, wouldn't you? Because you've been doing that for a lot longer. So let's try Alan and Carl. If y equals this and y equals this, how can I solve them? How can I solve it algebraically? I could set them equal to each other, couldn't I? Right? So if I have 750x plus 1,000, that would equal negative 100x squared plus 2800x plus 1,000. So what kind of problem is this? I know before this was a linear and a quadratic, but when I set them equal to each other, what kind of problem is it? It's quadratic, isn't it? How do I solve a quadratic? I want to get it equal to 0. So let's subtract 750x from both sides. What else can I subtract from both sides? 1,000. So 0 equals negative 100x squared plus 2050x. Now that turned out a lot nicer than some of you probably expected it to. The thousands happened to zero out on each side. That made it nicer because now I don't have to use quadratic formula. I can notice, what do both of these terms have in common? An x. Let's factor out an x. What's left if I factor out an x from the first term? Negative 100x. Good. What's left if I factor out an x from here? Good. Just 2050. How do I solve this now? Oh, that equals 0. Now I just have to set each factor equal to 0, don't I? Well, that first one's easy. Done. There's an answer. Negative 100x plus 2050 equals 0. If I subtract 2050x, or sorry, just 2050 from both sides, I get negative 100x equals 2050. If I divide both sides by 100, negative 100, excuse me, I get x equals 20.5. Wow, that number seems familiar. Boom. That was Alan and Carl also, wasn't it? That's what we did. Why did I get two answers? Oh, like when time is 0, they both have the same amount of money? And then at time at 20.5 years, they have the same amount of money? Does that make sense? Any questions about this? So why is this our last chapter? How much of this entire page did we do all year? A lot, right? We did this at the beginning, this at the middle, this at the end, and now we got to put it all together. That's why this last unit is called Tying It All Together. Isn't that a great title? No, I don't think so either, but that's okay. All right? Any questions about this? How much of this could you have done by yourself? All of it? Good. The rest of you, how much of it could you have done by yourself? 95%? Most of it? Good? Okay? You're feeling very confident? I want to show you something that we didn't talk about because I was not sure if we would have time or not, but I want to show you something real quick. And it has to do, I'm going to add a page that is a calculator page. I want you to do this so you remember how to do it if you need it again. Okay? We did it, I think, in like October, but hopefully you've slept since then. And I know some of you, that's your excuse when you can't remember. Well, I've slept since this, so let me remind you. There's another way to get the equation of a parabola besides doing the data and statistics page. Okay? And that is with a matrix. I just want to remind you. We know we're going to have to do reduced or echelon form. You remember that? Reduced or echelon form? Does anyone remember that? 3 of you, okay? And then menu, we want to create a matrix. That's not what I meant to do. I meant to do 7. You're going to have to wait. We're going to create a matrix. Yes, it's a matrix, and it's going to need 3 rows. Anybody remember how many columns? 4. 4. Okay, good. X term. Oh, sorry. Look real quick right here. What does that equation say? Ax squared plus bx plus c. That means for this first term in the matrix, I have to square the x term. Well, does anyone know what 0 squared is? 0. And then comes the x term. So, another 0. And then the c term, is there any x's in the c term? No, so we just put a 1. And then the y term. So 1,000. X squared term. Do you know what 14 squared is? Neither do I, but the calculator does. 14 squared. And then the x term, so 14. And then the c term goes here, so what do I put? 1. And then the y term, 20,600. Last one. X term. Do you know what 28 squared is? Neither do I. x term. The c term goes there, so what goes there? A 1. And then where's the equation come from? X squared term, x term, constant. Do you remember that at all? Some of you, yes, after I started showing you? Yeah? Maybe not right at the beginning, but right after I showed you? Okay. That's there, but so is the regression. So you can use either one, whichever one you're most comfortable with is fine. But you know how I like to, for you to know multiple ways. Okay? Are there any questions?